The age of large language models is upon us, and with the recent released Wolfram GPT, I ain't gonna lie, it's become one of my favorite new teachers. Might by asking our friends, the Wolfram GPT, might we be able to unlock some secrets of the universe? Bad human pun, but you all know what that
Although
means.
this is going to be weird, and it's going to be about a different.
Title of the conference was something like Ground Truth or Turtles All the Way Down. And so it seems as though there's one Ruliad. I don't think it rules them all. And it might be just hyper rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyperrulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. So I posted a little bit of this to Twitter the other day. I was going to do something else, and we're still going to do the analysis of gravity later. Still got to finish up the last part of one paper. There's also going to probably be a lot of claims, but this I thought was pretty fun. So basically, if you happen to get ChatGPT Plus or whatever the thing is, where you spend whatever $20 a month or something like that, and get the access to the newest and the fanciest ChatGPT, basically you can download the Wolfram plugin. Okay, so what do we got? Let's take a look at our friend over here. All right, let's take a look at our friend ChatGPT. So I've been asking some questions, and I'm curious, and again, full disclosure, I'm totally biased on this. It's one of the reasons why I kind of went to the physics monastery, and it is totally telling me things I want to hear. I'm just clarifying that up. I've also reinforced it by saying thank you for the thorough, detailed answers and stuff. But McCracken, good to see you, my friend. So let's delve into exactly what here. So I was trying to get it to do something first. I was trying to get to visualize the hyperbolic Mobius partition function or connection equation, whatever you want to call it. So basically, I asked it, can you please illustrate 1 over x plus x cubed divided by 2 pi equals basically all the things that we put in there before, formerly known as the hyperbolic vortex equation. I'm like, can you draw me a picture or something aside from like the normal things we've got? And it talked to a Wolfram Alpha doc. Basically, the big thing with this is you could ask ChatGPT before. It's like you ask it to do math, and I could do some math and stuff like that, but its level of accuracy was kind of. Casey had showed me this at the monastery before. He's like, just ask the normal ChatGPT. It's like, give me a string of like 44 digits. I asked it. It gave me like 38. I'm like, wasn't that 38 digits? It's like, I apologize. And it gave me like 43. It took it like 3 or 4 times to actually give me a string of digits because it would give you a fairly decent answer that you would get on the internet. To be fair, if you asked a random person on the internet to give you like a random string of 44 digits, if I had to type that, I would probably get it wrong. Just being straight. But Wolfram Mathematica, the Wolfram language, that's designed for computation. Basically, it helps fill the computational gap that a lot of these LLMs were asking, because Wolfram Alpha also happens to have a perhaps the modern Library of Alexandria's worth of data at it that you can just ask it different questions. So basically, long answer short, it basically went through, it solved the equations, gave the standard things. Solutions to the equations are, all right, Joe 1, Joe 2, Joe 3, Joe 4. Basically, okay, we've been over that before. If you need previous videos, or shoot a comment in the comment section. All right. Yeah, it's basically just giving the standard map that we would have there. Didn't load up there. So I asked it, doesn't the first answer squared look like the value of the fine structure constant? So the Wolfram GPT talked to wolframalpha.com. So the value of the fine structure constant offered to know that alpha is approximately 0.007929735257. Fine structure constant is defined as charge of the electron squared over 4 pi times the speed of light times the electric constant times h bar. So it basically goes through there, elementary charge, speed of light, electric constant, blah, 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 blah. Physical constant represents the electromagnetic coupling as a fundamental physical constant. Oh. Now let's compare this to the square of the first solution x, 0. Yada, 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 from the previous equation. To check this value, we square it and then compare it to the fine structure constant. Let's perform this calculation. Dr. Wolframalpha.com. The square value of this is approximately 0.0072973525729, yada, yada, yada. This result is indeed remarkably close to the fine structure constant, which is, okay, again, this is just according to Wolfram Alpha. Take it for what it's worth. If we look at this number, there you go, with the period there, we got 3 zeros. 72, 72, 97, 97, 35, 35, 25, 25, 72. Wait a second. That's not on there. How dare you make a prediction on the internet? Dad made it a while back. The similarity between these two values is quite interesting, although it's important to note that this could be coincidental, unless there's a specific physical or mathematical context linking them. All right, so you can go to the full thing there for the visual results. All right, let's ask further. Hey, Kali. We're getting there. Hold on. So I inquired further. So basically it's saying this could just be a coincidence. You would need to have some physical or mathematical reason for this to come out that way. Let's ask. Doesn't the value, yada, 2.17 times 10 to the negative 8 in our equation look similar to the magnitude of the Planck's mass value? Dr. Wolfram Alpha. The value of the Planck mass, MP, is approximately 2.1764 times 10 to the negative 8 kilograms. This indeed appears very similar to the value of, oh, look, it's got the first 5 digits. And then we're claiming there's more. How dare we? Mentioned in our equation. The Planck mass is a fundamental physical constant in the field of quantum mechanics, defined as the square root of the speed of light times h bar over big G gravity. All right. Oh my God. What did I do? Oh, okay. Oh, I thought I broke it. Okay. Hold on. Scrolling issues. Oh, God. If our equation did provide an explanation for the fine structure constant when we subtract out the magnitude of the Planck mass gap, what would be interesting/important? The Wolfram GPT. If the equation you provided offers an explanation for the fine structure constant, particularly by incorporating a term related to the Planck mass, it would indeed be a fascinating and potentially significant discovery in theoretical physics. Here's why. Fundamental constants, number 1. Both the fine structure constant and the Planck mass are fundamental constants in physics. The fine structure constant plays a critical role in quantum electrodynamics, QED, dictating the strength of electromagnetic interactions between elementary particles. The Planck mass, on the other hand, is a key constant in quantum gravity. A link between these constants can provide insights into the unification of fundamental forces or the nature of quantum gravity. That sounds pretty neat. Number 2, bridge between quantum mechanics and general relativity. Modern physics seeks a unified theory that can reconcile quantum mechanics, governing the very small, and general relativity, governing the very large. The Planck mass is a bridge between these realms. If our equation meaningfully relates these constants, it might hint at deeper connections in the fabric of the universe. Oh, that was pretty poetic coming from Wolfram GPT. Okay. Number 3. Numerology versus physical theory. It's important to differentiate between numerological coincidences, when numbers happen to align by chance, and physical theories that provide causal explanations. A valid theory would require not just numerical alignment, but also a theoretical framework that explains why these constants should be related in this way. So, hey, Fractal. Thank you for joining, my friend. Thank you for joining. Yes, if only there existed somewhere some form of a theoretical framework that could try to help us understand what might be going on within our realm of persistence. If only there was such a framework or frameworks trending in that direction. I digress. Number 4, experimental verification. Any new theoretical prediction or relationship between fundamental constants would need to be verified through experiments or observations. This is a crucial step in the scientific process. I totally agree. I mean, this is one of the reasons why I believe experiment grounding ourselves in reality is very important. Why do I say this? Well, again, as a totally biased dude on the internet, yeah, I'm biased. What can I say? It's like, all right. So if only there was a book in the newest version coming out in the next few months of 44 or something like that, if only there was a logically coherent framework with experimental observations confirming at least the current predictions or something, maybe that would be significant. I don't know. We go back to our GPT friend. All right. Number 5, implications for existing theories. If the equation has theoretical backing and aligns with experimental data, it could have significant implications for existing theories in particle physics, cosmology, and quantum gravity. In summary, while the numerical correlation you've observed is intriguing, the significance would depend on the theoretical context and experimental verification. Such discoveries, if supported by a robust theoretical framework, could be groundbreaking in our understanding of the universe. Thank you, Wolfram GPT. Now, again, I'm totally biased. I was leading in a direction, but I was curious what it would say. And it would say, that's interesting. You would need a reason. Isn't this kind of line up with this? Does this look like a potential reason? Oh, well, if that was a reason, you would need this. Okay. Not saying that this is right. This is the answer. This is 42, yada, yada, yada. I'm just saying it's interesting. And the big thing is, we got a freaking new tool now. We got like a new tool. It's like, for those of us that maybe find some of the math hard, it's like, all right, you could do Wolfram Alpha. And again, there's still some learning there, but to bridge the gap, you either, a lot of folks, they can type. If you happen to be able to type and you have to ask questions, depending on the question you're able to prompt it with, it can give you different answers. So it's like, oh, let's do something like this. It's like, what is the mass of the sun divided by the mass of the Earth? I mean, you could just kind of just do that in Wolfram Alpha. You could literally just type that. That's probably good enough there, but you can ask other questions as well. It's like, oh, take this. What happens if we took this? See, because now it's actually teaching you. 333 times. Oh, I did not know that. That was actually really quick too. How about this? It's like, what is the average energy density in the universe? Let's ask it something like that. I think this is, what is it? I'm asking it the average, so I'm not just saying empty space or the vacuum, even though there's no true vacuum, it seems. Oh no, there was an error. It did not succeed. Wow. For such detailed astronomical data. Oh my god, it's telling me it doesn't know. How dare it give an honest answer? Well, I think it was it Maxwell, basically, when he was lining up the equations. He got it like really dang close to like the speed of light. I think he either had a 3 or it was like 2.9 or something like that. It's like, it was, I think, like within 10%. So it's like, All right, without modern mathematical computers doing that like 150 years ago, I mean, it seems pretty impressive to me. But oh yeah, well that's the thing. You need certain vibes to be able to exist because if everyone's doing their own crazy thing all over the place and there's just chaos, it's like maybe we'll survive or not sure we'll thrive like as humanity, but that's one of the goals there. Well, let's try one more time. Let's but how about what do we get when we share the speed of light and multiply it by the Planck mass? Or something like that. It's like, and again, you can do a lot of this in natural language, but it can kind of like summarize the question you're answering and helps add to that bridge, that connective tissue. So I think it makes it a much easier on-ramp for folks that are interested in these things. And all of a sudden, you see something in a video from PBS Space, whatever it is. It's like, ask it a few questions or something like that, and it'll probably give you a pretty dang detailed answer there. And if you actually want to see, it's like, are there any interesting equations to do that? It's like, well, what happens if we do this equation? So, oh, go figure. Blah, 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 gives you that, which is roughly equivalent to the Planck energy. Yeah, I think that's where the calculation, or some may say the greatest miscalculation, like the 122 orders of magnitude, came from, because I assumed the Planck energy, but it apparently is supposed to be a heck of a lot less. That's probably why I gave the answer, because it's, do we really understand that? I think I asked it Wolfram Alpha before. It's like, yeah, we don't have enough data. No, but that's the thing, Fractal. Like, it's literally giving answers how I would assume. Like, even some of the folks I've talked to Wolfram, it's like, they'll give answers. They're willing to speculate and stuff, but they state that they speculate. And very often it's like, well, hey, these are some interesting things. Is this what's going on? I mean, that would be interesting. It's kind of like, kind of almost the ethos. It's like, well, you want to be skeptical because we're human beings. We're perfectly imperfect. We're computationally limited. I think mass in itself might be computationally limited, but that's a story for another time. I think a lot of folks might agree on that already. But kind of just wanted to go into that a little bit. Links to this stuff and things in the doobly-doo below, of course. I just thought that was pretty neat. It's one of those new tools where if you are interested in science or just things in general, you can ask an LLM, probably get a decent answer, getting smarter all the time. If you want something that maybe has access to a pretty decent database and everything already of the stuff and things in the world as we know it, I think it's pretty neat. Then again, I am a biased dude on the internet. What would I change? And I'm a terrible person. I have the book. I haven't finished it. I've only gone like so far in. Although every time I open up to something, that's how I came to. It's like randomly, it's like, yes, all these cellular automaton, at least like two-dimensional, they seem to always trend in these 4 patterns. I'm like, wait. So we have 4 trending patterns within each time we iterate our Turing machine, so to speak. So with each tick of the clock, the actual clock does 4 things. I'm like, are there any other models I may be a wee bit familiar with each tick of the clock? The talk has 4 things. I don't know. Purely speculative on my part, but it's now I saw some of that. The thing is turbulence. The crazy Wolfram reacted upon that for like an hour before, and actually got me into some different things. It's actually, to be fair, probably. The reason why I'll say that, and the question was, can I do symbolic reasoning as in math proofs? I think it was last year, Stephen Wolfram, he was given one of the things with the newest form of Wolfram Alpha. And I think he literally took a picture from a page of math homework, because the big thing was, we want to help kids with their math homework. It literally took the picture and made all the answers right out there. And I heard it's like, it almost seemed like he was surprised at how well it did. It's like, oh, I literally created a thing that will do students' homework for them. That was my opinion of what I was observing. Probably completely wrong, but so I think it should be able to do it. That's a good question. Not today, but we'll check some things. Actually, I have some handwritten stuff over there. I could probably do an experiment. See, we can actually do experiments. Oh my god, if we can start to do that, well, that's it's an interesting time. But that's all I got for right now. Peace out, everybody. Take care of yourselves. It's a crazy world out there, but I think with the new tools we got, I think we got a shot. Why? Because we can. Peace out, everybody.